right, ladies and germs, listen up. Shh. All right, so my digital clock's a minute slow, but I have 8:10 on my watch, so we're gonna move on. All right, so that's what we're doing. All right, so first off, let me set up my triangle very quickly. So I'm just gonna draw a random point C. Let's do about right here. Then I'm gonna do 30 degrees. So right here. All right, so there's my triangle. Now, shh. Angle C is 30 degrees because that's the one we measured. What's angle B? 90 degrees because it's a vertical and a horizontal intersecting. So automatically that should be perpendicular. What about A? 60 degrees. All right. Now, it's angle A comes from 60 degrees and it is a what type of triangle? It's a right triangle. So this is the new type of special right triangle. So yesterday we talked about 45, 45, 90. Today it's 30, 60, 90. All right, so there's two types of special right triangles, 45, 45, 90, and 30, 60, 90. Now, the only connection between the two is that they both have their own set of special rules to help you find the sides. All right, but they're not the same rules. So the stuff we learned yesterday with 45, 45, 90 does not necessarily apply to 30, 60, 90. All right. Now, which leg is shorter, AB or BC? AB would be shorter. Why? If you didn't measure it. Right. So a 30-degree angle will not create a bigger line than a 60-degree angle if they're in the same triangle. All right, it's like physically impossible. So, and that's because a 30-degree angle will not make a bigger line than a 60-degree angle. All right. Now, I'm going to take a minute and measure my sides. So, let's see. All right, so I know mine's not in centimeters, but this is inches. So this would be about right. Thank you. So this would be 2.8 inches. That's 1.4. That's 2.4. All right. So, how many times bigger is my hypotenuse than my short leg? What should I do? I would divide it. So I would do 2.8 divided by 1.4. So just for labeling's sake, this is hypotenuse. Across from the 30-degree angle is what we're going to call your short leg. Across from your 60 is your long leg. So if I do 2.8 divided by 1.4, you should get 2. So depending on how you measured your sides, you should got somewhere around 2. All right. So your hypotenuse is twice the size of your short leg. Now, what should have been pretty much the same was you should have gotten around times 2 from your hypotenuse to short leg. That is actually the rule for how you go from the short leg to the hypotenuse. All right. Now, that means when I'm doing these down here, your short leg, this is hypotenuse. If we find our short leg, we just do 16 divided by 2, which is 8. This is the hypotenuse. I want my short leg, so this would be 5. This is my short leg, and I want my hypotenuse, so that'll be 18. Everyone follows so far? Now, it then asks you to do Pythagorean theorem to find those long legs for all 3 of those triangles. So I told you that you wanted to do Pythagorean theorem and simplify the radical so you see the connection. So what did you get for this long leg? Anyone? So I don't want a decimal, I want a simplified radical. 8 square root 3. What about this one? 5 square root 3. What about this one? 9 square root 3. So how many times bigger is the long leg than the short leg? The square root of 3. So it's times the square root of 3. So essentially what you guys just did is you discovered the rules for a 30, 60, 90 triangle. All right. So if we look at the right side. So once again, this is a type of special right triangle. And it's specifically the 30, 60, 90 triangle. Now, if you're given a right triangle and they mark one of the other angles to be 30 or 60, it's automatically a 30, 60, 90 triangle. All right. If it's a right triangle, because by process of elimination, if one of the angles is 30 and the other angle is 90, the other angle has to be 60. All right. So the rule for a 30, 60, 90 triangle is, say the right angle's here, 30's here, 60's here. First off, you always start by labeling what's your long leg, your hypotenuse, and your short leg. Hypotenuse is always across from the 90-degree angle. That's always going to be consistent. Your short leg is always across from the 30-degree angle. And your long leg is always going to be across from your 60-degree angle. So if you ever have a special right triangle, it's a 30, 60, 90, that's how you should start it. Now, your short leg, we're just going to call A. So, to go from short leg to long leg, what did we end up multiplying by? Square root of 3. So your long leg will be A square root of 3. So that means if we want to go from short leg to long leg, we would multiply by the square root of 3, the short leg. If we want to go from long leg to short leg, what do you think I'm going to do? Divide the long leg by the square root of 3. Now, hypotenuse. What was the connection between the hypotenuse and the short leg? That was double it. So this would be 2A. So from short leg to hypotenuse, we would multiply the short leg by 2. Hypotenuse to short leg, we would divide the hypotenuse by 2. Now, there is no connection, so I would make a note of this. There is no direct connection from hypotenuse to long leg. All right. If you're given the hypotenuse and they want the long leg, you have to find the short leg first, and vice versa. So if they want long leg to hypotenuse, you got to find the short leg first. All right. So the short leg is the middleman. All right. So I would write that down just so you know there's no direct path from the long leg to the the long leg to the hypotenuse and vice versa. So you can really only go in this direction or this direction. All right, any questions on the rules? All right, so now, as long as you're given one side and you know it's a 30, 60, 90, you can find the rest. So first off, number 1, letter A. What side was I given? Short leg, long leg, or hypotenuse? Short leg. Why? It's across from the 30. So I need to find my hypotenuse and my long leg. What's my hypotenuse? Hypotenuse. 8. 4 times 2, that's 8. What's my long leg? 4 square root 3. All right, letter B. Was I given my short leg, long leg, or hypotenuse? Long leg. It's across from the 60. So I have my short leg and my hypotenuse to find. So for my long leg, how do I get my short leg? Divide by square root of 3. What do I get? 15. Then how do I get my hypotenuse? 15 times 2, which is 30. Good. All right. Now it says find the area of the rectangle given NQPO. So if this is 30 degrees, this has to be 60 degrees. So this is 90 degrees because it's a rectangle. Diagonal is 40. So this diagonal line right here is 40. So what did they end up giving me? They gave you the hypotenuse. So how do I get the short leg? Divide by 2. So 40 divided by 2 is 20. Where would I put it? NO or NQ? It's NO. So this would be 20 because that's my short leg. How do I get my long leg? Multiply by the square root of 3. So that's 20 square root of 3. Now, what's the area of the rectangle? So what do? Times them together. So 20 times 20 square root 3. You just got to multiply the two 20s together. So what's 20 times 20? 400. So this would be 400 square root 3 units cubed. Not cubed, sorry, squared. We're doing volume in math 3, so cubes on the brain. All right, the last one. DEF is dilated by a factor of 1.5. And they want us to know what's the ratio for EF prime and DE prime. So DEF is not the one that's dilated. We have to actually dilate it. So, and it'll end up being a bigger triangle, but just for space. So D prime, E prime, F prime. This is still 60, 30, right angle. So, recall how to dilate. What do? I multiply 11 square root 3 times 1.5. So I just need to multiply the 11 and the 1.5. So what's 11 times 1.5? 16.5. So this would be 16.5 square root 3. So what would my short leg be? 16.5. What would my long leg be? 33. So they want EF prime over DE prime. So this would be 16.5 square root 3 over 16.5. So if I simplified it down, what do I get? The square root of 3. Good. Any questions on the warm-up? All right, so hold on to the ruler and protractor for right now, but go ahead and take out your packet and turn to page 9. And I promise I will check homework eventually, but a lot of y'all needed help, so I didn't get a chance to. Now, you're going to also want that trig table paper that I gave you yesterday. So take that out as well. All right, now, before I do anything, we know that we're dealing with trig ratios today, just like yesterday. So before I do anything, what did I tell you? You always need to check your calculator to be in if you're dealing with trig. Degree mode. Can someone tell me how to do the degree mode in your calculator? At least on TI. Click mode. Make sure degrees highlighted. If it's not, use your arrow keys, go down, and change it. All right. So I don't think, unless one of my math threes reset their calculators yesterday, it should be in degree mode, but still double check because you never know. All right. So right now, take a minute, double check, make sure your calculator's in degree mode. Because if it's not, your answers are going to be all kinds of funky. All right. So yesterday, we did trig ratios. So we started by just discussing how to set up a trig ratio and how to use a trig table to kind of figure out which angle's which. All right. Now, today we're actually going to learn about how to find missing angles using those trig ratios without the help of a trig table. All right, so we're going to have the trig table out first just to kind of give us a good reference guide, but then I'm going to show you how to do it in the calculator. All right, so first off, let's do a little reviewing. Who remembers that little acronym that I gave you yesterday to help you remember? SOHCAHTOA. Caught another hippie tripping on acid. So let's do the so part first. So that means that sine of theta, remember theta means an angle measure, is equal to what? What's the ratio for sine? Opposite over hypotenuse. Cosine, we're in the cup part of theta, is equal to what ratio? Adjacent over hypotenuse. And then tangent, which is the TOA of theta, is what? Opposite over adjacent. All right. So I'll probably jot those down at the top just because we're going to be using those a lot today. And remember, opposite and adjacent is all relative to the what? Nope. 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 It's in reference to what? How do I figure out which is my opposite and which is my adjacent? But that can change depending on your reference, not point, angle. So depending on your reference angle, that determines your opposite and adjacent. Your hypotenuse is always going to be across from the 90-degree angle. All right. And by the way, your reference angle will hardly ever be your 90-degree angle. It's always going to be one of the acutes. It's very rare when it is. But it doesn't really do anything. It's still the same process. All right. So first things first, we're just going to re-practice finding our ratios. All right. And we're not going to simplify anything. So first off, sine of A. So I'm using A as my reference angle. So sine is what? Opposite over hypotenuse. What's my opposite? 1. What's my hypotenuse? 2. Cosine of A. What is it? Adjacent over hypotenuse. So that means that it's what? Square root of 3 over 2. Tangent is what? Opposite over adjacent. So what would it be? Now, typically you may be itching to mess with that because there's a square root in the denominator. Don't worry about it for right now, because when it comes to putting in your calculator, you don't need to simplify it. All right, now we're dealing with a reference angle of C. So C is my new reference angle. So that means my opposite and adjacent switch. So sine is opposite over hypotenuse. So what is it now? Square root 3 over 2. Cosine of C, what is it? 1/2. And then tangent of C? Square root 3 over 1. So that's just a review from yesterday. All right. Any questions so far? Now, remember the relationship between the sine and cosine values of the complementary angles A and C. So what's the relationship between them? They flip. And it's because their opposite and adjacent flip, depending on the reference angle. Now, using your calculator in degree mode, which of the following is the correct value of the measure of angle A? So, let's think about this logically. All right. How do you think I can use my calculator? Or, and better yet, let's not use our calculator yet because I haven't even broached what that is. All right. Haven't even broached what that is yet, so we're not going to do that yet, but let's use our trig table. So, on your trig table, okay, if I actually did make this decimals, what's 1/2? 0.5. In your calculator, what is the approximate, let's say 2 decimal places for square root of 3 over 2? So in your calculator, put in square root of 3 over 2. What do you get in decimals? 0.87. So 0.87. And then do 1 over square root of 3. What would you get in your calculator? 0.57. So go to your trig table and tell me which value of A gives you close to all 3 of those values for sine, cosine, and tangent. 30. All right. So just to recap, if you look at your trig table, I'm looking for 0.5 for sine. So I'm going to first just go and see if I can find 0.5. It's right here. So 0.5 for sine is right here. And then I double check to make sure cosine and tangent are correct. Cosine should be about 8.7. That'll round up. And then 5.7, 5.8, it'll round up. So we're going to use the angle of 30. Now, I will show you in a second how to get it with your calculator, but we're not there yet. Now, since trigonometric ratios only depend on the measure of a particular acute angle, your calculator has them stored in it. All right. So again, basically that trig table I gave you, your calculator has that entire table stored in it and more. All right. So, which of the following is the closest length of MN in a right triangle element shown below? And we're going to use a trigonometric ratio that makes the most sense given the angle and the one side known. So, this is how you will calculate. So we're given angle L. So that means everything we do is going to be in reference to angle L. So what's the first thing that I told you should get in the habit of always doing when you're dealing with trig? Labeling your sides opposite, adjacent, hypotenuse, so you know what you're dealing with. All right. So what is my hypotenuse? Which side? NLLN. So this is my hypotenuse. What is my adjacent? LM is my adjacent. So that means MN is my opposite. And it wants us to find MN. So we're going to call this X. Now, this is where you have to decide which ratio makes the most sense to use. So, let me ask you this. All right. Given the sides, all right, that I have given, including the one we marked X. So we have LM and MN. And look what they're marked as. Which trig ratio would make the most sense to use? So look at the two sides that are marked. It would be tangent. Why? Right. So they gave you the adjacent, and we're trying to find the opposite. So because those are the two we're trying to use, tangent would make the most sense to use since tangent is opposite over adjacent. So we're going to do just that. So we're going to set it up using 42 as our theta. So we're going to set it up as tangent of 42 would be equal to what? What's the ratio? X over 20. All right. Now, tangent of 42 is a number, okay? It's not something we're solving for. It's just a number you can put in your calculator. So how do you think I'm going to solve for X? So before I even put anything in my calculator, how do you think I'm going to solve for X? You could put over 1 and cross multiply, or what's the more straightforward way? So let's just cross multiply. If I cross multiply, I have 20 times tangent of 42. Never multiply a number to the number in the parentheses. You don't mess with the angle measure, ever. Is equal to X. So this right here is what I'm going to put in my calculator. So in my calculator, I'm going to type in 20 tangent, of 42. Close the parentheses and then hit enter. So my side, MN, is about what? 18. So it'd be 3. Yes, ma'am. You could have also done that, but yeah, you could have done that too. So the other way you could have done it if you didn't want to use your calculator, you could have, if you recognized it was tangent, you could have used your trig table, gotten the number for tangent, and then multiplied it by 20. You could have done that as well. All right. But you won't always have your trig table on you, so it's a good idea to get used to doing it in your calculator as well. Now, exercise 3. If ABC is a right triangle where A is the right angle. All right, so let's just draw a quick sketch of this. A, B, C. A is the right angle. C is 34 degrees. Which of the following measurements are most closely to match these conditions? All right. So, first off, 34 is our reference angle. So let's just go ahead and mark our corresponding sides. So what side is my opposite? AB, adjacent, AC. So that means BC is my hypotenuse. Now, essentially, we're just kind of checking to see which ratios make the most sense. All right. So, in other words, depending on what sides we get or they give us, we'll check the ratio compared to the trig function of that angle measure. All right. So, first off, AB and BC. All right. AB is your opposite, BC is your hypotenuse. So, what trig function should I use? Sine. So, we're going to check to see if sine of 34 is equal to what? 18 over 12. So in your calculator, put in sine of 34, or you can look at your trig table, and then put 18 over 12 in your calculator and see if it matches up. So everyone should be putting this in their calculator. So put this part in your calculator, and then put this part in your calculator and see if they equal to each other. They should not. All right. So just to kind of recap, if I put sine of 34, I get that. 18 over 12, I get that. So they're not even close. All right, so one's out. All right, still dealing with AB and BC, so opposite hypotenuse, so we're still dealing with sine. So I'm testing to see if sine of 34 is equal to 14 over 25. Now, you should have already put sine of 34 in your calculator, so you just need to put 14 over 25, see if it matches up. Does it match up, or is it pretty close? All right, we're saying it's pretty close, so 14 divided by 25. Pretty close, all right? 0.56, that would, in sine of 34, will round up to 0.56. So we're thinking it's going to be number 2, but we still need to check the others. So we're thinking that 2 may be our answer. So AC and BC, so we have adjacent and the hypotenuse. So what trig function are we using? Cosine. So I'm doing the cosine of 34, and I want it to equal what? 11 over 17. So check to see if the cosine of 34 is equal to 11 over 17. No, it shouldn't be. Last one, AC and AB. So that is our adjacent and our opposite. So what am I using? Tangent. So we're seeing if the tangent of 34 is equal to what? 12 over 15. Check in your calculator, see if it is. Nope. So 2 is our answer. And guys, we could have stopped at 2 since we found out it was it, but I wanted you guys to see how you would set up all the answer choices. Any questions so far? All right. Now, in the old days, instead of having a calculator, students had to read the trigonometric ratios from a table, which I already gave you. All right. So without using a calculator, what's the cosine of 63? So if we look at this table that they give us, Or you can look at your table. What would be the cosine of 63? .4540. All right. So 0.4540. Now, let's say that you didn't have your yellow table in front of you and you just had the table that they gave you. All right. So we know that it's based off of a right triangle, and one of the angles has to be 63. All right. Now, that means the other angle has to be what? 27. Now, why is that important? Why do you think that's important? Because 27's on here. Now, we know that cosine, in reference to the 63, would be adjacent over hypotenuse. So this would be my adjacent, opposite, hypotenuse. So, in terms of 27, all right, we're using adjacent hypotenuse for 63. So for 27, what would it be? So if 27 is now your reference angle, what's the adjacent now? So the adjacent side for 63 is the what to 27? Is it the opposite of the adjacent or hypotenuse? It's the opposite side. So this would be the opposite side for 27, and we still have the hypotenuse as consistent. So for 27, so in other words, the cosine of 63 would be equal to the what of 27? Hold on, guys, I get disconnected. Currently experiencing technical difficulties. Please hold. But yes, the cosine of 63 would be the same thing as the sine of 27. And that's what you would do. All right, so if this was a crap. So if this was a question on your test, all right, and I gave you the trig table, but you couldn't use the one that I gave you, that's how you would figure it out. You would figure out what the other angle was in your right triangle, and then discover whether the cosine of 63, what it is in relation to the other angle. And if we look, sine of 27, 0.4540, which is what you got on your trig table when you looked at it for cosine of 63. Does that make sense? How I did that? All right. Now, let's look at B. So which angle in the table is the closest to the measure of angle A given the right triangle shown below? So before we even start, we need to figure out what trig function we'll be using. So for the side that's labeled 50, what is that in relation to A? It's its opposite. What about the 77? That's your adjacent. So we're given the opposite and the adjacent side. So what are we using? Tangent. So tangent of A would be equal to what? 50 over 77. Good. Now, take a minute, put 50 over 77 in your calculator and get it to 4 decimal places. So be 0. What? 6494. All right. So now on your table, look for tangent being 6.96494. Right. It's right here. And it's connected to the 33. So we're saying that angle A is equal to 33 degrees. So that's how you would use a trig table. Now, let's say that, this was the ACT or the SAT, and you don't get a trig table. All right? You only get a calculator. Here's how you would do it in your calculator. So first off, what they're going to want us to do is look at the next kind of numbers right here. What do you notice about those sine, cosine, tangent for letter C? It's raised to a -1 power. Now, does anyone remember what it means in math for something to be raised to the -1 power, what it represents? It represents what? Technically, we're trying to find the angle. It helps us find the angle, yes. But I'm looking for a specific word. Well, we know that x1 rule wise, but we flip it to the opposite side of the fraction bar, but that's not what I'm thinking of. Not necessarily division. Does anyone remember what this notation means? So, it's connected to f of x. What does f of x usually represent? Y, or a function. So this would represent the what? You've seen it before in Math 1.
The opposite.
The opposite. Good. And what's the word for opposite in math? Inverse. There you go. This is the inverse of these trig functions. That's what this represents. All right. So these are what we call arcsine, arctangent, arccosine, which is known as the inverse of them. In other words, it undoes sine, cosine, tangent. So all of these are inverse. So that's inverse sine, inverse cosine, inverse tangent. Now, how do we do that in your calculator? Well, it's very straightforward. So, if you prefer to the poster over here, how you get the inverse in your calculator, do not just hit like the sine key and try and raise it to the -1 power. It's not going to work.
Second.
All right, you have to hit second, and then whatever key you're trying to use. So sine, cosine, or tangent, and that will give you the inverse. All right, so take a minute. Let's do the sine of the first one together. So we're going to do second sine. So that gives us the inverse sine. And then it'll be 0.4, what is it? 389? 384. It's 26.001, blah, 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 blah. So let's round to the nearest whole number. So what would that be? 26. So this represents 26 degrees. All right. Arcsine. So that's the other name for it. So you either see the inverse as sine of -1. You may also see it as arcsine of some number. All right. That's the two different ways you see it. It means the same thing. They're both the inverse. All right. Take a minute. Find the inverse of cosine of that number. Round it to the nearest whole number. So what'd you guys get? 34 degrees. All right, now find the inverse tangent. (31 degrees). So, my question to you is, what do you think the purpose of an inverse trigonometric function is? In other words, you find the angle measure, the reference angle, but specifically, what do you think an inverse trig does? I'll give you a hint. It's kind of like the same thing as multiplication to division or addition to subtraction. It cancels it out or it undoes it. All right. So, in other words, what it does is that it undoes, the sine, cosine, and tangent functions to give us the reference angle. So just to note, if I did the inverse sine of 1, these two would cancel each other out. I'm left with 1. All right. Same thing for cosine. If you did the inverse cosine of 1, be 1. Inverse tangent of 1, it'd be 1. All right. They literally cancel each other out. All right. Now, why is that important? Because sometimes with triangles, they want you to find the reference angle. They tell you which angle we're using to reference, but they don't give us the measure. They only give us enough side lengths to use trig to find it. All right. So just remember, inverse sine is sine to the negative 1 of x, inverse cosine, and inverse tangent. Now notice how they're using x instead of theta. Why do you think they're using x instead of theta? Because it's not an angle, all right? What you're putting in for x is actually your ratio, all right, which comes from your sides. So it's not actually your angle measure, whereas sine of theta represents taking your angle measure. So, last problem. So, given angle E, all right, we're going to call this theta because we don't know what it is. All right. Given the side lengths that we have, we're going to set up the trig ratio. Just the trig ratio, not the inverse. So, we got 8 and we got 11. So, in reference to angle E, 8 is our what side? Adjacent. 11 is our what side? Hypotenuse. So we're given the adjacent and hypotenuse. So what trig function am I using? Cosine. So I'm going to write this as cosine of theta, because we don't know what it is equal to what? What's the ratio? 8/11. So treat this as if we were solving a equation. All right, we're solving for theta. This is kind of how I would write it out if I was solving for it. So this would be my original. So I'm going to rewrite what we had up top. All right. Now, I need to get theta by itself. So how do I undo the cosine again? You take the inverse cosine of it. Or arc cosine, however you want to put it. Because arc cosine of theta is just theta. And remember, whatever I do to one side of the equation, I got to do to what? Other side. So I'm going to take the inverse cosine of the other side. So this cancels out. So I get theta is equal to the inverse cosine of 8/11. Go ahead and put that in your calculator. You don't need theta. You just need to put this part. So just put that part in your calculator because that's a number. It's about 43 degrees. So theta would equal about 43 degrees. All right. So in other words, once you get x or theta or whatever by itself, put it in your calculator. Whatever's on the other side of the equation, and then that'll be your answer. Trig isn't that hard, guys. It's just knowing, first off, what the trig ratios are. That's the hardest part right there, is remembering that. And then making sure that you label the sides correctly in relation to the reference angle. That's the hardest part. The hardest part, as much as I've taught trig before, the hardest part that I've seen, or the biggest issue that I've seen students struggle with, is they pick the wrong trig ratio. All right? Nope. Because SOHCAHTOA, right there. As long as you remember.
That's right, SOHCAHTOA. It is on your calculator.
SOHCAHTOA. It's not hard.
It is on the
Oh, if you physically spell out SOHCAHTOA, you got it right there. All right. So your homework for tonight, and since we got about 20 minutes left, I'm going to come around and check the homework from last night and from Monday. But your homework for tonight is pages 11 and 12. Now, just for, because number one, it has you guys do some measuring and you don't really have millimeters. I'm just going to give it to you. So number one, these are 51 millimeters, 43 millimeters, and 67 millimeters. All right. It's on the board. So those are the measures of that triangle that you were supposed to measure by yourself, but I'll save you some time. All right, so go ahead and get started on that. I'm going to come around and check your homework from yesterday and the day before. So yesterday was pages 7 and 8. Mondays was 3 through 4. So have that ready to go. I'm going to come around and check.